Okay, let's have a look at this question. I'm warning you, I'm pretty tired, so let's see how today goes. Okay. An engineer is using a machine to cut a flat square of aerogel. Oh, that's the NASA material, isn't it? Of 144 centimeters squared. If there is a maximum error tolerance in the area of 8, how accurately must the engineer cut on the sides, assuming all sides have the same length? Yeah, okay, let's think. So here, um, the epsilon, I think, is 8 centimeters squared. And we're saying there exists a delta such that absolute, and we'll call the function A, area of x minus 144. So the difference between the area and 144, that should be less than epsilon, less than epsilon 8. So that would be x squared minus 12 squared less than 8. So let's stop this. Because x could be a little less than 12 or a little more than 12. So maybe I don't really want to square both sides. I could have x minus 12 times x plus 12 absolute less than 8. Um, I have to think about. I'm so tired. What's the best way to solve this? I really don't want to resort to squaring both sides. So we'll consider the situation. Either x is less than 12 or x is more than 12. So if we take the first case, x is less than 12, then we'll just we'll have a negative here. So then we would have the equation 12 minus x times x plus 12 less than 8. So multiplying this out, I would get minus x squared in the middle, and I'd have here 12x and a minus 12x, so plus 144 is less than 8. So then I would have x squared is more than 144 minus 8, that's 136. And then, or if x is more than 12, then actually we'll just go to x squared minus 144 is less than 8, because we can drop the modulus sign, the absolute sign, because both these guys are positive. So then we'd have x squared less than 144 plus 8, which is 152. So we have either this or this, x squared less than 152. But we just remember also in the first one, this is and x is less than 12. And here this is and x is more than 12. So we'll have x is between minus root 136 and root 136. But also x has to be less than 12. So basically this would push up to 12 then. So by putting these two inequalities together and something seems wrong here. This seems a bit too big. Oh, I'm sorry. I have my inequality the wrong way around. X squared needs to be more than 136. So that means x would have to be more than root 136 and x has to be less than 12. So putting them together, you get x has to be between 12 and root 136. That's the first possibility. Or this is the one I should have had the other way around. X minus 152 and root 152, and x is more than 12, so that means x has to be between 12 and root 152. So if we want to collapse these two inequalities into one inequality, we would have x has to be less than it could be either. So x could either be in the first camp or the second camp. So x has to be less than root 152. And if it's just a little bit less, then it'll fall into this one. Basically, the or here in combining the inequalities is a union. So we're just kind of putting these two together. So we would get this then as the inequality. Now, can we write that though as a absolute? So just this is about 12.32. And then the other one's 11.66. So this one here is 11.66, and then this one here is 152 is 13.32. So let's see. The middle of these two is root 38 plus root 34. If you add these two together and divide by 2, so this upper one, root 52, up here, that distance there is root 38 minus root 34, and then at the lower end, so that's good. That distance is also root 38 minus root 34. So I think to put this into the more familiar form, it would be x minus root 38 plus root 34 has to be less than root 38 minus root 34. So the delta on the x is root 38 minus root 34. Yeah. Hmm. Root 38 plus root 34 is 11.995. I felt like that should have been 12. Like, it's really weird that it wasn't 12. It makes me feel like I've mistyped something. Something really stupid. Yeah, 136. 152. I don't know what the answer is. Oh, they kept it as decimals. I didn't need to be so precise. Epsilon 8, delta 0.33. A is 12 though, L is 144. Yeah. Yeah. Let's see, root 38 minus root 34. Yep, 0.333. The only thing I'm disagreeing on here, no, not even the A. And I am disagreeing on the A. The L, yeah, it's only the A I'm disagreeing on. It's really interesting that it wasn't 12. It's like remarkably close to 12, but not 12. Because it's quadratic and not linear. I wonder. I wonder if it's their mistake. I feel like perhaps it might be. I understand why it seems like the x should be 12, because that's the square root of 144. But because the error grows with a square beyond the 12, you actually have to undershoot the 12 to have a more uniform error under and over. Yeah, actually, you know what? I'm really going to take a chance. I'm really going to take a chance with saying that it's root 38 plus root 34, which is nearly 12, but a tiny bit under. Uh, yeah, yeah. I think, despite being exhausted, I think I will say the A. Um, the A is not 12. It's 11.995. Yeah, and I'll put a ticket in. That's what I'll do. So I spent a lot longer on this question than I thought, but it was an interesting one, and I think it was worth it. So I'll just finish on doing 200 now. Okay. Uh, Use a precise definition of limit to prove that the following limit does not exist. Let's test it out. So apparently, for all epsilon greater than 0, there exists a delta such that f of x minus 1 should be less than, minus L should be less than epsilon, as long as x minus 1 is less than delta. So let's calculate this. That's x minus 1 over x minus 1 minus L is less than epsilon. How will I simplify this? X minus 1 over x minus 1 minus, say, L over 1. Do I want to? Yeah, maybe I do. Okay. X minus 1 minus L times x minus 1. Okay, less than epsilon. Yeah. Maybe I should do my split again. So either x is more than 1 or x is less than 1. So in the case of x more than 1, that's x minus 1 minus L times x minus 1 over x minus 1 less than epsilon. So that would be x 1 minus L. This doesn't feel right. Doesn't feel right. I think I should tackle this a different way. I need to choose an epsilon here that shows that this can be false. So okay, let's think about this. Okay, let's consider the case when x minus 1 is a positive. That would mean we'd get absolute of 1 minus L less than epsilon, which should mean then that, oh yeah, that we can choose epsilon to equal just modulus of 1 minus L, and there's no way this could hold for any x, for any x more than 1. Now if we choose the case that x minus 1 is less than 0, then we'll get minus 1 minus L less than epsilon, which means 1 plus L is less than epsilon. So again, just choose epsilon equal to 1 plus L. Okay. So, putting that together, if you choose epsilon equal to whichever is bigger, the maximum of absolute of 1 minus L, an absolute of 1 plus L. Even if the first case was true, then you've chosen an epsilon either equal to or bigger than this. And even if the second case was true, you would have chosen an epsilon that either is equal to or is bigger than this. So if you choose epsilon equal to that, we can never have this situation, f of x minus L less than epsilon, because either epsilon will equal or exceed this here, because either epsilon will equal or exceed. Oh no, exceeding is good, isn't it? We need to go with the other one. Sorry, minimum. Sorry, apologies. It's okay if your epsilon is too big. So yeah, okay. So sorry, I'll correct that. Okay, so I want a situation. I should have chosen the minimum. So make epsilon equal the minimum of either 1 minus L or 1 plus L. So let's think about that again. If we're in this situation and we went with this guy, then that's definitely false. If we went with this guy, then it's only because that was smaller than this, and that would make an equation that's false. Yeah, sorry, should have been the minimum. I said maximum. Yeah. Okay, so the minimum of this or this then. Yeah. So either you'll get fx minus L equals epsilon, which is not what we need, or fx minus L will be less than something which is smaller than fx minus L. So I think the only problem we could have is x equals 1, but we can't have x equal 1 because remember we're searching for x minus 1 to be between 0 and delta. So yeah, I think this proof, and it's long-winded. I know I made a couple of mistakes, but I think it's okay now. Hopefully, if there's any problems, you can let me know. Thanks for watching, and I'll see you again next time.